Alright, so we're gonna bring up Canopy. Selenium and what's the other one? I'm not going to really describe what's going on today until I get someone else in, which hopefully will happen in just a couple minutes. I'm just going to do a little bit of background reading. Oh, hey, we've got some people in stream now. Everybody, put some in there. Let me know who's here. I suppose I could just like pop open the chat bar and see too, but right now I'm just bringing up a couple like reference links that we're probably going to need as we start working through this. I just landed on, I think, what I want to call the library itself. I found it on I did what every library author does, I think, which was Google search synonyms of the core concept. And the core concept is puppeteer. Like that's the library we'll be hopefully building on top of. And a puppet is kind of like a doll. And, well, what's an F word for a doll? You've got figurine. So I think we're going to call the library Figurine. So with that in mind, let's start. So I said I was going to make this a library like a real library, like something I would put out and be proud of, you know, with a proper CI pipeline and all those things. And so what I like for that is mini scaffold. Mini scaffold is a nice template that's sort of like project scaffold in its intent, but it's made by a buddy of mine, the Angry Bird. He does a whole bunch of like .NET utilities. And so this one includes a whole bunch of fun stuff in it. So we're going to use this as our base. Where's the list of features? I don't think he's done that yet, but it includes built-in stuff for Travis and AppVeyor, decent git ignores and editor configs and things like that, GitHub issue templates, packet out of the box, tests, and code coverage is the other thing. So you get a lot of good stuff in here, which is pretty nice. So before we get started, I'm going to make sure I have the newest version of that. And if I make my font a little bit smaller, we should be able to see these a little bit easier. So there's our mini scaffold right there. So let's try it. We said we were going to call this one Figurine. My GitHub username is Baron Fell. I don't think we need this lang flag anymore because I think it was around .NET SDK 2.1.300 that they made the language default so that if there's only one language for a template, it gets that by default, but we're just going to do that and see. So one thing I don't think that we've fixed quite yet in the .NET SDK either is permissions. So what you're doing with these templates is unzipping a package essentially. And until recently, the .NET zip archive didn't have this option for extra data, which is where the Linux permissions would reside. So it's there now. It just hasn't flowed to all the different frameworks, is my understanding. So as we can see here, it's telling us that we need to apply some permissions here. So if we go to Figurine and see what we got in here, we need to build.sh. Da-da-da. So now our build script will run. So we're just going to test this real quick and make sure our pipeline works. And if that's the case, then I'll show you a little bit of what we get for free out of that for before we dive into looking at our particular library. There we go. Hi, Victor. It's good to see you, man. Thanks for logging on. So we got the fake build going here. I don't know how much you heard, but we're going to call this thing Figurine, which is sort of like a puppet since we're building on top of Puppeteer. So I'm just getting our scaffolding in place for an actual build pipeline and that sort of thing before we start coding itself. This gives us code coverage, packet for dependencies, all that fun stuff. And we're in the wrong directory here, so I'm just gonna. So I don't know if you saw this or not, but what I like to use for new projects is mini scaffold as a template. Hey. So I mean, there's also project scaffold. There's also the sort of like big pile of .NET new templates that you can get, but for sort of general purpose libraries, I like mini scaffolding, or I like mini scaffold. So we're here in Figurine. Let's go ahead and open VS Code. I was sort of waffling between VS Code and Writer. I've been using Writer a lot more lately for like mixed solutions where I've got F# and C# in there, or where I've got type providers. But Code is my first love, and so I figured we'd go with that. So we've got our library with all of our normal stuff, and this is all good to go. All right, so we're in a happy place here as far as our library is concerned. As far as what our inspiration is, it's Canopy. I don't know how many of you have had the chance to use Canopy before, but this and Fake were like the two libraries that were Trojan horses for me in my F# career. So like doing Canopy tests to automate browser tests was one of the first like nice DSL succinct language sort of light bulb moments for me. So we're going to aim to mimic as much of the Canopy API as possible with this completely different driver, because Canopy is built on top of Selenium, which is a sort of cross-browser API. And it's very nice. It works on .NET Core now. It allows for parallel testing now. Canopy does on top of Selenium. But there are some people who like Selenium. Yep, Jeremy Abbott's in the same place as me. Some people don't like Selenium. Some people like Puppeteer because it's like tightly bound to Chrome and Chromium, and it uses the debug tools API for those browsers to run actions. So as a result, you can do things that are Chrome specific or that Selenium doesn't expose because they're not necessarily cross-browser, like PDFs or screenshots or evaluating random JavaScript. I know you can do this in Selenium, it's just a little hard. So what we're going to do is looking at sort of the API that's available to us in Puppeteer, see how closely we can mimic some of Canopy, and then hopefully turn it into an actual library with build scripts and everything. So speaking of build scripts, build.fsx, you get a lot out of mini scaffold. That like it takes you a lot of the way towards having a production ready Fake deploy. So first off, you're on Fake 5, so you're in the new model of Fake, which is modular and .NET Core ready and all those things. So it gets you a nice little release notes pipeline, so you can annotate your release notes like this and have an actual version number come out of that and NuGet metadata and all that fun stuff, which is just a good practice to have in general. But if we, sorry for the scrolling, if we go down to the bottom, you've got a sort of typical pipeline where you restore your dependencies, build your project, test your project, generate coverage, pack it up, do source link, and then push it all up to GitHub. This is pretty cool. This is nice too, automatically making Git and GitHub releases and that sort of thing. There's a target in here to watch your test too, which is really just a wrapper around .NET Watch of this project. So we'll get to that in a bit. The big things, the things that I think every single project now should do, is this source link step. So source link, if you don't know, lets you get very, very nice IntelliSense. Oh, wrong one. Packet.dependencies. It lets you sort of autonomously grab the source of a dependency you have if it's hosted on any sort of accessible source code provider. So GitHub's the classic example. Where is it? Right here. So that's on the command line, but there are some other ones that you can do too. Like you can go grab sourcelink.github, for example, and just include this in your build. And then in your build.fsx script, you can add a you can add this source link create tag right here, and it will put a bunch of information in your DLL, so that when somebody hits F12 or right-click go to definition or whatever, or debug steps into your library, it will download the source code for them, bring it up in their editor, and let them step through. You used to be able to do this with like symbol sources in Visual Studio, but this source link stuff is excellent because it works cross editor much more easily. And you can either this sort of ties in with PDBs. Like you can either have the source in a remote destination, or you can bundle the source in the library. No matter how you do it, you should definitely do it. There's some getting started stuff on .NET Source Link, and it is just really easy to get into it these days. Like I said, you just add a couple properties here and add a single packet or NuGet reference, and you're good to go. Like you're done. So really good reward for very little effort. I highly suggest everybody do it. So we're gonna close out of some typos that I got there, and we're going to do a few things. We're gonna go grab our new dependency. It's gonna be Puppeteer Sharp. So we're gonna go over to fugit.org, which if you don't know Fugit, that's another one you really should. It's like NuGet.org, but you get some additional sort of metadata. In fact, let's go see the difference between the two. So if we look up puppeteer.net right here, or whatever the actual package was, which was Puppeteer Sharp. That's it. K-block, we're good to go. So Puppeteer Sharp. Here's the page for it. You get versions information, release notes, you get how to install it in different ways, what its dependencies are, all fun stuff. But if you take the same exact URL and hit F and go to Fugit with it, you get a little bit more information. And for that information, you pay a little bit of a price time-wise. So let's go ahead while we're waiting on that. Let's go to our packet dependencies file and go ahead and bring this guy in. Oh, I know what the problem is. Cool. So now if I do that. So I've got an alias for packet that assumes I'm in a Git repository, and it will use a git command to find the root of that repository, and then go to the .packet folder and invoke packet.exe via mono. And so what it was doing there was like going to a different directory than I intended because I hadn't initialized a Git repository in this directory. So fixed. Downloading our new dependencies. Let's see where we are right now. Let's just go ahead and do Let's see what all we're adding. This is all fine. The default git ignore makes it so that we don't get anything we don't want. Yeah, we want all this. So this is a nice bit of the code coverage. One thing that's good is we end up pushing up code coverage reports from AltCover, just a website you can click through. So that's kind of nice. There's no documentation generation in this framework right now, but we should be able to easily pull that out of like Project Scaffold and use it. I think the blocker on that right now is because F# formatting, the tool that we typically use for that, I think has a blocker on .NET Core. So we'll get there once we've got a skeleton of the library up. In the meantime, Fugit came up with Puppeteer Sharp. Grab our dependency. Cool. So Fugit came up with Puppeteer Sharp. This is the new spec itself, so it's kind of raw right here. But what's really nice is you can do, you can go back in time to different versions, but you can also do diffs between the version you're on here and prior versions. And this is kind of really nice in my opinion. Sometimes it's hard to evaluate API differences between versions of a library. And so anytime at work when I'm looking at updating a particular library now, I'll come do an API diff on Fugit and see what the delta is. And so this will come up here in a second and we'll just get like a list of all the different types and members in there and see what changed. It's not, strictly speaking, necessary for what we're going to do today, but I do like being able to browse through all these different types and see how to use them, right? So you can, once this comes up, we should be able to see the details of the iBrowser type. So let me go make sure that we have our Puppeteer Sharp. Great. So let's do a little bit of renaming here. We're going to call this, well, I'll leave it LibraryFS for right now. Figurine, we'll leave it right there. Yeah, so here's the API diff I was talking about. They added an asynchronous wait is what it looks like on particular browsers. So that's cool. All right, first things first, let's go over to Canopy and completely wholesale lift. Yes, Victor, sorry. All the chat stuff is on a monitor to my left, and so I miss it. But yeah, there are tools for code coverage in F#. There's AltCover, which is the one that comes in Mini Scaffold. So this is here. It's got tons of tests. It's pretty cool to look at. And it has a visualizer tool now, which is kind of cool. The nice thing about AltCover, and the reason Mini Scaffold chose it as opposed to some of the others, is that it hasn't left Mono by the wayside. So a lot of the new ones are .NET Core and .NET Framework only. This one has Mono. Jimmy and I still have investments in Mono, so we're leaning on this one. Also, there's some nice, like there's a fake module, there you go, that Steve Gilliam has made here. So he's got a nice little fake wrapper around it. So this is one of them. What are some of the others? Oh, and the way all of these things work, Victor, is they provide, yes, there we go. They provide some targets is how they work. Let's see if I can give you an example real quick. There's all its testing samples, which is why that's all like that. It's probably just under AltCover. Nope. Tool, perhaps? This is the .NET Global tool that you can use to run things. Is it under build? Suffice to say, there's some MS build targets that come with it that implicitly inject. Yeah, that's sort of another reason why we like alt cover, because Steve wrote it in F sharp. Um, so, but yeah, so it comes with a command line tool to actually do it, .NET local and global tool versions, MS Build tasks, all sorts of fun stuff. He's got a backstory of why as well. And Scott Hanselman has another good article on sort of .NET Core or .NET Core code coverage, which includes coverlet, which I think I would say is the more mainstream option at this point. Victor, yeah, it is language agnostic. It's just running assemblies and instrumenting .NET assemblies. So works with VBNet too. Like it's all of these tools should work across all DLLs. It's just some of them might be better at interpreting like some of the weird sequence points that you get in F# compiler sequence points sometimes. Okay, so took a little while to come up, but here's some more stuff you can do with Fugit. Like you can investigate the different members, see the documentation. You can jump between different types. You can actually flip over to the code as well. You'll get like a decompiled version of the code here. This is just a dummy interface, so there's not really anything interesting there. So at this point, I want to start by like going to Canopy and stealing some of their functions. So unlike Canopy sort of has a synchronous mode and a parallel mode, and I want to go off of the parallel mode for sure, and I want to go off of the instanced parallel mode as well. The distinction here is the functions mode always have a browser as the last parameter. So you might have the URL function like this. In the functions mode, you run the URL function, you give it a URL to go to, and you give it a particular browser instance to execute that on. And so if you wanted to do your tests in parallel, you could spin up a bunch of different browsers and pass them through. That's fine. That's great. It gets a little verbose though, and objects aren't the devil. So instead you can do this sort of thing, an instance that takes a browser and you execute instance member instructions. Like all of these things just shadow the Canopy underlying functions. There's nothing crazy there. So I guess we should do the functions first to be proper, because you can always just overlay the object layer on top of that. So given that, then let's just copy a bunch of the functions that we want to write. None of this is going to work, and that's fine. That's fun stuff. So let's just mimic a bunch of stuff real quick. Let JS script will fail with. Boom. We're going to want this a lot, so let's just do that. Put string text. I don't know what our sort of driver abstraction is going to be yet, so let's just make a type alias for it. And we can fill that in once we bring in the once we actually bring in the dependency and start sort of feeling out what some of these things are going to be. Don't care really about that. Don't care about highlights initially. I really just want to like go to URLs and write stuff in an input and read stuff from an input. I think seems fine. Wait for conditions are going to be important. Wait for condition. And the condition. Nah. Let's not get ahead of ourselves. Yep. Find selector. We're not going to have an explicit timeout, I don't think. Let's leave it right here. Canopy does this, handles like timeouts on things by having some global config. I think instead what I want to do for these functions is have the driver that you're on eventually have like a configuration object on it. So you could sort of statefully change the timeout for a particular operation and then come out of it like that. That's one thing I hit with Canopy right now is I've got a helper function called like do with timeout, where you pass in what you actually want to do, and a timeout that you want to mutate it to, and so it pops the current timeout, puts the new one, and go. Yes, Dimitri. There are project scaffolds. I didn't use project scaffold itself. I used a .NET Core template called Mini Scaffold. There are tons of other ones though. This is all using the new .NET SDK. There are tons of other scaffolds as well. You get a few out of the box for F#. As you can see, I've got a few here for Saturn and SafeStack. Here's the Mini Scaffold one. I think Project Scaffold itself also has a version of this, but let me go check that before I go spouting misinformation. Also, Dimitri, thanks for coming by. It's good to see more people in the stream. I am not sure it's been converted yet. Yeah, it has not been converted yet. I believe there's an issue to make it a... It's such a good resource that I feel like it's a shame not to have a .NET New template, you know? Yeah, so I don't think it's there quite yet. So Mini Scaffold is what we're using now, and what I like to use, because it includes, hit this again real quick, a very complete build script that includes source linking your dependencies, and releasing to GitHub, and generating code coverage. And some people expressed interest in the code coverage, so one more time, that's alt cover by Steve Gillum. So be sure and check that out. It's really cool. We're trying to integrate this more at my work so we can have like some confidence about some of the changes that we make. Okay, so let's do one more. Let's curl you, and then pop in the driver there. That seems like enough to at least start stubbing some stuff out. So now I'm going to look over at Puppeteer Sharp, and we're going to take a look about how this thing is intended to be used. A couple questions I want to ask here, because I have some experience with Canopy, is do they intend this API to be single-threaded? Or is there sort of like a contextual or configuration object that you can use to have multiple Puppeteer instances going simultaneously? And so this is actually a decent use case for FSI. I'm not sure I want to go through that right now, though, because this is a .NET Standard component, and we're still waiting on FSI in .NET Core, .NET Standard. So I think we'll just do a couple iterations, maybe with some tests instead, and see why this guy didn't come up. Okay, that's fine. Yeah, we don't have any problems there. This said current settings VT1 will be used. Well, okay, what is the runtime identifier here? That's fine. I don't care about netcore app 2.0 at all. Let's do a packet install again and get ourselves into a good state. One thing I should have made sure to do was that a .NET run on the test project actually does something. So we'll check that out real quick. It looks like this uses, yeah, it uses expecto by default. So that'll be perfectly fine to just .NET run. Let's go ahead and reload that sucker. There's our FS project and our tests. So one other thing we will likely need to do, is in both of our references here, bring up, come on now, packet.dependencies. There we go. My hands are confused between JetBrains Writer and VS Code. The do anything keystroke in JetBrains Writer is, I think, the Apple key and T, but in VS Code it's Apple key and P, and so I keep making that mistake. So we're on Puppeteer Sharp. We're going to go to Packet. I did it again. Put it in there. Put it in there. Do another packet install. And then the other thing I find with a lot of the new IDEs is you have to do not only a packet install, but a packet restore and a .NET restore to get everything refreshed. So go ahead and do a restore. That should be pretty much a no-op because we already have everything. Yep. And then a .NET restore. And we'll see if that makes, yeah. See if that makes VS Code happy. Project was restored using NetCore app 205, but with current settings. Let's check out the info here. Why restored with 205? It's that one right there. Let me see what my global.json is. I don't have a global.json. Let's go do that. I always forget the format of this. It's something like SDK version blob. Yep, that's exactly what we want. Need to talk to Jimmy about getting that in there. So come back over here. We will just add a new file at this level. Oh, I already did it. Plop that in there. Except I think, do I have 500 installed? I have 401 installed, so we're going to do that just for uniformity. So now if I go .NET restore, let's see if that does it right for us. Hey, that is a cool tip, Jeremy. Thank you for that. I did not know it was there. I saw it when I did .NET New, like all the way down here, but I didn't know what it did. So thank you. All right, so checking this out now. That looked like it was fine. So now let's see if Ionide is happy. If we clear the cache and refresh. Moment of truth. Ah, load failed. All right, I'm gonna try EAP real quick and see if that works. We'll just bounce between them. What I really want is I want the tests to be workable so that I can just .NET watch on the tests and use that as sort of like a quasi REPL. Just stub out some stuff real quick and get a feel for how the library works. We're going to open a new solution. I guess I was sort of hoping it would take me to Figurine. Alright, let's see how sad my machine gets when I have multiple FSAC runtimes going. We're just going to try a one-off thing over here too. We're going to do a .NET run. And just, oh, it's not going to work because I have multiple runtimes. Let's try that. Hey, sweet, EAP worked. We'll just go with that then, I guess, for the interim. Alright, so now that we got this, we're going to go look at what our actual API is in this case. I think it's going to be Puppeteer Sharp proper. Yeah. All right, so we're going to do something really simple. Our first thing is just going to be, we're just going to go to Google. So we're going to screenshots, yada yada yada. That looks like a static. Okay, you can connect to an already running one. This browser static. Let's see what's on that class. Okay, so you can new things up there. Okay, so it looks like it's got the same sort of model as Canopy does. There's sort of two sides to it: the static side and the not static side. Okay, connection, blah 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 blah. Ignore that stuff. Let's see what's in a browser context. Go to implementations. Alright, so you want a connection. And you I don't want that. I don't want any of that. So let's go look at the browser itself and see if we can find a better way to connect with the browser. Boom. Okay, there we go. Never mind. Right there. So we want Puppeteer.launch async. This is going to be fun too. Let's see. I think there's a test case async. There is. So we can get all native now. Boop. Launch async with some options and a logger factory. So we'll, for the actual library, we might pull in something like a Serilogger or a loggery facade or something like that, or give somebody a mechanism to provide their own logger facade so that we can shove it in there. But for now, we're just going to go launch options. I am curious, however, what's in that launch options. Headless, great. Ignore errors. Oh, interesting, it bundles Chromium. So one thing we'll probably have to provide then is a way for a user to set that path. Slow down everything. Arbitrary arguments. Default timeouts. Sure. Environment variables. Okay, that's all fine. I think headless is fine by default. And all right, if not, sentence be determined the default. Okay, sure. So the cool thing about this library is it communicates with a Chrome instance over WebSockets, which is nice. Instead of sort of screen scraping to determine what's going on. So if we just get a new browser here, and then wait, or what am I doing? Async await task. So we'll just get our browser here. Our browser's disposable would be the next thing I want to know. Hey, it is. So we should probably use Bang instead. So now we're just going to go b URL. What is it, like new page? So I think we're going to want to not have the user, like we don't necessarily want the user to care about a particular page necessarily. All these actions operate on a particular page. Yeah, it's a single tab. Okay, so what we could do in a parallel mode is have something around a page and have the page be the unit of parallelization. Because it's possible for multiple Chrome instances to be doing different things on different tabs, perhaps. So one thing we'll want to look at is if it's possible to have different tabs doing things simultaneously, which I think it might be with WebSockets, instead of having to like actually do UI input. But if it's not possible to do that, then what we're going to want to do is spin up multiple browsers sort of behind the scenes. So we'll have to take that one in a second. And we could spin up a parallelization test right now, or in a moment, to figure that out. So let's say page dot go to. Everything's async, so it's going to be a little bit of a pain for a user to use. So we're going to want to expose these methods with asyncs to be like idiomatic. So we'll do page go to async https google.com. What is our secondary? Oh yeah. The other thing we could do is bring in Task Builder v2 because that's getting to be increasingly popular, but I'm not sure. Await unit task or async result perhaps. Oh, I know what it is. The return type here is a Boolean, or you get a response back. So response, what does response have on it? Okay, so we are probably going to want to extract out some sort of result structure from this. So what they've done is you've got this response type in here, and it's sort of doing the classic C# thing where you've got a Boolean that some things are successful, or some properties are valid when the Boolean is set, and some properties are invalid when the Boolean is set. So we might want to do something to protect the user from even seeing these things. Like I don't want the user to have to care about a response necessarily. I want to be able to reify the response into an exception. So we'll leave that as it is right now. We'll do a little like if resp dot okay, if not that, then fail with couldn't get to URL, else continue on through, which means we don't even need that. So now we should be able to say something like page dot URL should equal expect equal page URL should have gone to Google. So this is a little bit more verbose than doing it in interactive. I think, like, if we are smart about building our tests here, though, .NET watch, .NET watch run, we can use have these just be something that we build as we go about sort of fleshing out each side of the application. Or the library. We'll abstract parts of these things and rewrite this to use our new API as we sort of evolve it. So coming back over here. Aha! Chromium revision is not downloaded. Run browser fetcher.download async. So let's see what the deal is there. Or download Chromium manually. Okay, so let's try that. So that is going to be a thing that we're going to want to see. There's probably a configuration that tells us to use Chrome. There's those launch options. So let's do that, just so I don't have to download something else right now. We'll see where Chrome is. What? Oh, I'm gonna have to find the binary, aren't I? probably just going to be in library application or yeah, there it is. Google Chrome.app somewhere in here. This is where you see how bad I am at my command line foo. So that's the app itself. That may be what we need. Yeah, and it's inside a particular versioned folder, which makes sense. Okay, so let's use the more recent one. So this is one of those things that's going to be really, really annoying if we make somebody specify. So we might want to probe for common places, because which didn't do anything there for me. So on OS X, then I bet you there's a sort of which analog for .apps, so we could ask the OS for that. But in the meantime, let's try just launching it ourselves. That's the wrong editor. Here we go. And this launch option was called executable path. So we will say executable path equals blah, 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 blah. We're going to be super bad in just hard code because we are still in the exploratory phase. So now, back over here, the test should start running. Path executable does not exist. Did it just want Google Chrome .app? Oh, I used the .app again. So if we come back over here and change that instead. And one more time. Yeah, that's what I was thinking. There's an about config that we just hit that might be programmatically accessible. But I guess at that point, if you're thinking about asking Chrome to launch itself and give you the path, you know where the path to Chrome is already. So why bother? Failed to launch Chrome. Path executable does not exist. Well, that's great. Oh, because I'm a dingus and put a space in there. And double dingus, I didn't actually update the path from the tool. I'll get it right, guys, I promise. I'll get it right. While I'm waiting for that, I'm actually sort of curious to look at the there. I kind of want to just commit and push up. Hey, there we go. We actually got something, folks. We'll just go ahead and pull that out because duplication makes my eyes twitch in weird ways. All right, so that should be just fine, and we can go places and do things now. So let's think up a better model for this. And this is where it's going to start to get pretty subjective. So open up to your sharp, type driver equals browser. I don't know why we would even have that now that we know it's as simple as just browser. Match case. You know what? I don't actually know how to do find and replace in this tool. So, again, please don't judge. So, as we found, to go to a URL, we definitely don't want that. So let's have some context then. So instead of just a driver, we're going to say that we're going to have the user give us some sort of browser context, and that's going to include the browser itself. And ideally, like, this would be opaque, right? We might put some helpful members off of here, like with browser dot new, right? No. It might have some internal, like what the current page is, because that's really the thing that matters. This is the right. So we could put helper members and stuff off of this browser context, and hopefully not have what we don't need. I guess the better way to say that would be just to have what we need. And so if we pass browser contexts into these things instead, now we can say that URL is just also, okay, so Canopy scripts are also written sort of synchronously, generally speaking. So we can do a lot of like blocking result stuff here if we wanted to, just to present a similar API to them. So if instead we did d.page. Go to async u let response equal go to u async dot, well, let's not even bother doing the conversions. Let's just do let's make a little helper method here. Let's call it task, and let's just have a force in here. System.threading.tasks.task t equals t.result, because we're bad people. Awesome, I'm gonna check that out, Yoshi. Yeah, that was sort of the thing I was thinking at. Like, open knows what you want to do. So you could use, yeah, I guess at that point, if you use open to get it, then you can get like the child process ID and get the path off of it. That would do it nicely. So actually, that's a decent point, because there's a couple different pathways that I saw in the documentation for the launch options. So if I can find my tab where we had launch options. Yep, here we go. If we look at the launch options, there was a connection, I think, on there. Or it was part of browser itself where you would pass in a connection. And that probably overthinking it. Suffice to say, we have a couple different ways to get the the URL. One thing that we could do, well, we're not actually going to do that yet. So that would do it right there. So we would also need and we don't need that. We're just going to do like a check here that takes a response. And we're just going to do an assertion here that R is okay. If not, then fail with. Right, because we're just going to force this, and then response dot check. And that'll do it. So that is a hacky, sort of internally stateful fellow there. So we're going to go functions. We'll open functions in the context of this guy right here, and do. So we also need a helper to create a browser context. So we'll say like if we have a module browser. And I'm doing this so many times repeatedly that we're just going to have it open in the context of the entire namespace. And then I can pull that out like that. And so then we'll just have a let create from exe path string equals launch. Ooh, that's actually what we should do. No. I was thinking of going, like making a little DSL off of a launch options module that let you just sort of function compose all the different launch options, but that's not a use case that we're doing right now. So we'll just do it like this and sort of organically grow it. So if we have a user do this and we make some launch options and then we say, we make a browser off of that. How do we do it over here? Yeah, puppeteer launch async, there we go. Then we force our guide, then we get our browser, and that's fine, and then we'll package it up in a browser context. We'll stick our domain in here, and we'll go so this gets us a browser equals all that nonsense, and then we'll say let p equals b.newPageAsync task.force because I'm a bad person, and then we'll just say page equals p, and there's our context. And so now we have somebody, we've given somebody a browser context, and they can begin to thread it through. And use a whole bunch of the other methods. So somebody could write a test now that says, for a particular, like say, well, these tests are going to run in parallel by default because we're in expecto. So the context itself would look like browser, create from exe, Chrome path, and then URL to expected URL context. And so now at this point, that's going to do our check for us, right? Because we've got the response checking inside that helper method. And so now what we would do instead is what current URL, boom. What is the URL that we are at in our context? So we can start hiding some of the grossness about keeping track of where we are inside this context and just expose members that people might need. So that seems okay. So that was not terrible. It's also not super fully featured. We'll get there. At some point, it might be worth it to define a DU of like common execution types, or a set of lambda functions for that launch option. So somebody could sort of build up a launch options.default into launch options with exe. That would plop it in. Launch options headless, that sort of stuff. And then just plop it into like a create from launch options. Like that would also be very easy to make here. So we're also sort of forcing someone to create a new instance here. The other option would be Puppeteer. This static class has a connect async as well, right? So we could do that as well. The other thing is we might want to, like maybe behind the scenes, we infer, like, so we hit that version problem with Chromium. So maybe behind the scenes, we always use latest Chromium, but provide a method for someone to pin the particular version in the browser context so that when we, or before we launch, we check and verify that the browser does exist. So there's a whole bunch of different ways we could take this to make it a little bit more ergonomic. So I'm going to devolve this a little bit, and we're going to pull out this bit and put it all in this create function. So if we have our browser and our options, this is sort of our generic one. We think the page is going to be the main unit of work that we want to work on, and so the browser itself is sort of eh. So actually, so we will need to be able to dispose this thing, and then interface disposable. We have to preserve these semantics with member dispose. Nope. Yep. Come on now. Equals dispose. Cool. So now when we set this up, we'll say b or dispose equals b dot dispose, and that will do it for us. And so now create from exe will just be a specialization of the overall create function. And this will just be create with that, like that. So we started with a specific instance and we sort of generalized it to something that is a little bit more open. In the future, we could tweak this a few different ways. We could have a DU here of connection or launch options and use the appropriate Puppeteer method depending on which one we want to do. In fact, let's do that. Let's go type launch method, or yeah, we'll call it that. We've got launch of launch options, and we've got connect of what are our options for connect async here? Takes, there you go, connect options. Boom. All right, so now this is going to take a launch method. And we'll say let factory equal match method with launch. And connect will be connect async. There you go. So now we go options or method into factory. Well, that's not quite going to work. That'll work though. All right, so we'll just go task.force factory and be good to go there. Cool. And so now this is going to be a launch More parens. Some people hate parens. I'm okay with them. So now we see how our tests handled that. They're fine. So that's Ural. That is like the most basic one. So let's go do something a little bit more interesting, and do something like this. So one thing, oh, of course there was a slash in there. Boop. One thing that Canopy does is let you set different timeouts for different type of operations you're going to do. So when you're on a page, the time it should take to find a particular element in the page should be relatively small. But when you're navigating to a page in the first place, that might need a bit of a wider timeout, right? Due to network problems, due to just the amount of time it takes to download JavaScript. And so they've got these different timeouts. Compare timeouts, they've got like a navigate timeout, right? And so at this point, this structure is getting a bit big. And so we might want to define a default, like wrap this in a page.option or something. But in the meantime, we will say that the default compare timeout is equal to system.timespan.fromSeconds. We'll say it should take no more than 10 seconds to find an element on the page. And the navigate timeout by default, system.timespan. Oh, system's already open. Yay. From seconds, 30. All right, we'll just pick some arbitrary numbers and we'll tweak them as we do more stuff. So now, when we look at something like find selector, this is going to be interesting. d.page.find. Aha. So at this point, we need to go check out some more of our documentation. So we've got a page at this point. And some of the methods that we were just looking at it, or looking on at it. Oh my goodness, look at how many of them there are. Yeah, there are a bunch. That's going to take a while. What I'm looking to see here is the concept of like getting a reference to the element, right? So if there is an element handle, that's what I wanted right there. So you can do all sorts of instance-based things. Like this is your escape hatch in Canopy. Over there they call it an I element, I think. So if you can get a handle to a thing via this find method that we are about to write here, or find by selector, then you're good to go. So you should have query selector async. Cool. Yeah. So we'll just go singular here and we'll pass in the selector. And the result of this is going to be our element handle. Now we can be a little bit smarter about this, I think. We might get a null, so we can handle that. So task.force, and then option.obj. Cool, boom. Now we can find things on the page. So if we go to google.com and we want to get a reference to this particular input right here, that is a disgusting class name. So we could find it by its title or by its ARIA label. ARIA label seems more stable to me. ARIA label is used by like accessibility tools. So I would expect that to be a bit more stable. So we can do a selector here. Let's see what we can do. We can do an input whose ARIA label equals search. Cool, we got it. So that's our selector right there. So let's do a test. Let's say this actually isn't needed anymore because we're doing all the stuff blocking because we're terrible people. Boom. Test case can get element via selector. There we go. CTX equal browser. So one thing that would be really nice that we might want to consider is this to sort of separate the rules around constructing a browser, or the rules around like finding a browser, from getting like an active page context. Because as it stands right now, each time we run this test, we're going to new up a new version of the browser, which is not bad. That's how Canopy works right now, I believe. The capability that we might have with Puppeteer is to have one central browser with multiple pages. And so if we go too much further with this, we might want to look at encapsulating that, maybe not in the browser context, but have a different sort of launch context. And then you could, and that would control the lifetime of the browser. And then the context that we pass to the user to do their scripting with, that would just be the context of a particular page. So that's an option. That's an option. And so this might turn into less of a record and more like a safe constructor function that provides. Anyway, so yeah, so we were going to go to we'll just plop some constants out here. So if we go to Google homepage, and then we find selector, our selector right here on that page, then we should be able to assert is some element should have found the search input. So now let's run that and see. Some options that we can, or what we will want to do in this for sure, is we have this context with this timeout. We are going to want to see if this provides a cancellation token overload, which it doesn't look like it will. So we may need to dig down into some of these. Yeah, so we're going to need a combinator to run a task with a particular timeout. Because none of these allow for a cancellation token to be passed into them. So if we really want to enforce a timeout, that's the way you have to do it, is a shared cancellation token source and flow that through. So we might look at making that happen here in just a second. So if we have a unit to task T. It has to be unit because it needs to be delayed. You can't attach a cancellation token to a task that's already running. So, but we should be just about to run here. Excellent, 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 excellent. One thing that might be interesting while we're doing this development is to set that headless flag on the launch options to false, so we can see it pop up and verify. Because like it says that we're doing things there, but one thing that we can do is try and do some. I know, but we just asserted that it was, so we'll clean this up. type async. So we're going to put something in there. And then change the headless value to false so we can validate that it's actually going. So we want some text to put in there. So we're going to be what are our text options here? We're going to go see that. Oh, it's a delay. Yeah, whatever. Don't care about that. So we'll hack this real quick. And again, we have to do the thing because polymorphism. All right, so now what we should see when we do this is we should actually see the browser pop up. We should see it select the search input in question. We should see it right in there. So that'll be a nice sort of can we find things. And at that point, we can start working on a little bit of infrastructure, like firing off tasks with timeouts via cancellation tokens. And, oh, t.wait. That's how that works for non-value holding tasks. So we can, that'll give us a decent base, and we can start looking at how to hook in the cancellation tokens there. That also is exactly what we need to do wait for as well. Waiting for a predicate with a particular timeout, i.e. that compare timeout that we already sort of set aside. Yeah, hey, there we go. We go to Google, we found the input, and we put our text in. Boom, bada bing. Cannot get simpler than that. Okay, so that is proving to work fairly well. Okay, so some gross things. So what would be nice next is the write thing in there. So taking a little bit of inspiration from Canopy, there are, that's right to select. Yes, that's right. They do some matching here. So they take an object in here and figure out what it is, like by doing type testing. And then they have sort of delegating methods to do particular things. So if it is an element reference that they want to write to, you can just write to it directly. But if it's a CSS selector, they have to go do the select and then write to it. So there's some subtlety there. We can sort of sidestep that initially by just saying that we're going to require you to have an element reference first, and then just sort of expand it from there. So let's go implement write. I'm going to write a particular text to a particular element, where element in this case is an element handle. And this is just going to be exactly what our test was. We're not going to make use of the type options on this, because all that was a delay, so we don't particularly care about that. So then we can come back here and just go write hello from Figurine to element.value. So cool. So that's our like write test. Another thing, if we wanted to, we could do a set of sort of helper functions on the element itself to grab properties, manipulate it and all that stuff. But Canopy doesn't do that. Canopy just lets you, like, once you have the reference to the thing, you can interact with it in a bunch of different ways. There are some Canopy selectors that do like select or click or put string, which is, put string is like a write that also echoes out what you're trying to write. So there's a whole bunch of different little API nooks and crannies that we can get into here. But at this point, we've got enough to where we can stop and have something useful, because you can get an element and you can write to it. Oh, the last thing we should do is read. Once we have that, we are, yeah, there we go, hello from Figurine. We can have enough to look at organizing and documenting our library, doing that sort of initial commit, and doing the initial like deploy release stuff. So that'll be sort of the next part once we do read here. Read. So if we're going to read from an element, this is just going to be element dot. So this is where it gets a little interesting too. Depending on the type of element it is, you are going to have to look at different values. So as always, let's look at Canopy and see what it did, because it probably did it right. So they have this safe read, yep, text of. I thought it was in line. It is not. Oh, there it was. There it is. Yeah, so like I said, based on the element, get particular, well, they say attributes here, but it's properties. So we're just going to sort of mimic that. So that's typing. So now we have to see what kind of element it is, which I don't think we've seen yet on the data model here. So let's go look at documentation. Ooh, accessibility. Sorry, I got distracted looking at the API there. So by and large, on the, what do we got? We got an element handle. What I would like to see is some sort of textual representation. Well, the type of the, like I want to get the tag name. Let's do a little bit of investigation. We have an element here, so let's see what it is. Element. Well, that's not actually going to get us anything because it doesn't have a an F# formatted toString. But that's enough to give us something to hook on so we can debug onto it and put a breakpoint ahead of where that would be. I think if we just did like a breakpoint here, we might not be able to access the value property. Ah. All right, let's try it again. This time the right way. So we're doing build. Should probably stop .NET Watch going on in the background just so that my poor computer doesn't die. All right, started the tests. Doing the builds. Doing the builds. Okay, so now we're actually launched. We should hit the breakpoint here in just a moment. We can see that Expecto is running the tests. It's running that first test. There we go. All right, so we're here. Here's our element. Here's our value. So let's look at what we got here. Here, we're going to make this a little bit bigger so that you all can see it too. Or I was going to try to, but I guess not. So that's our client. We don't really care about that. I think the remote object is going to be where all the good stuff is. This is a Newtonsoft J object, and so it's going to be a little interesting to see as we're investigating through here. But we could probably toString, yeah, because it's a J object, we could toString the entire thing and get like an actual representation here. So let's try that. Let's toString element.value. Here's our console, there should be a place to evaluate debug expressions. Aha, here we go. Evaluate an expression. Boom. All right, so that's our, I'm going to copy the value and, whoop. A thing that you can do in yeah, there we go. I want a new scratch. Oh, that's it? Oh, goodness. So we could do a little bit more investigation and see if the description is always going to be like tag and then just the list of classes. So let's do a bunch of things. If we can get we're gonna make a new test case where we scrape that entire page. And we're gonna first make our context like you do. We're really going to want to make that multi-page before too much longer. And go to Google and see how we can get on a page all of the element handles. So what we're looking for is like an element handle array. I know you can get an element handle array by doing like a select many on the, oh, there it was, just walked right past it. Yeah, on the select all there. So if there was a query selector that got everything, then naturally that would work. And then we could just iterate through the list of results there, seeing what their types and their descriptions were. Because the other bit in our, what is that? Yeah. So the other bit, not in there, but wherever our scratch was, I think I got rid of it. It had an HTML input element class name on it. And so we might need to pivot off of the class name instead. So let's see what that looks like. Nope, not a valid selector. If anybody knows the CSS selector that gets you all elements, that would be great. w3schools.com. There we go. Universal selector. If it's frickin' star, I'm not going to be surprised. I'm just going to be disappointed in myself. I mean, yes, that's everything. I wonder, let's see what we get. We're going to have to implement find many selector first, which will take a selector and give you back the enumerable of results. d.page.query. Yep, all async selector. Again, anytime we interact with the page, we're going to want to come back here and do a timeout, which might be reasonable. Like, you could define a custom computation expression to do things on a page that would take this state sort of internally and do that. That would be one way enforcing that all of your different operations had access to and use the timeout. But we will get there in just a moment. Task.force. So now we have an element handle. Oh, it's complaining over here because we were still debugging. Cool. All right, so we will get our element handle array and we will see what's in it. Let elements equal find selector, find many selector star off of our current context. And now we'll just for element in elements do type tab new line description tab %s, and then we'll do a new line and a separator just so we can see what's going on, and do element dot I think it was class name, or sorry, it was the inner remote object is what it was. Ew, boy. So we're just gonna have to go for it. Do a string on both of these. We're just gonna do raw JSON access. Sure, no problem. At some point, if we want any sort of confidence over that, we might have to just dump it out and see, or see if we can find a spec for what the actual remote object structure is going to be, and maybe use something like the JSON type writer or something to codify those so that we can do something better than whatever we were doing before. Did we... Bollocks. Let's see. Ah, there it is. I forgot that's what it was. So it was class name and description. That was the other bit. Knew I had it around there somewhere. So let's take a breakpoint here. Run that sucker. Nope, not run. Debug that sucker, and see what we can see about the contents of our page. What would be slightly annoying is if this universal selector only returned the page as a whole, like it did over here. Like it returned the HTML and that's it. That might be Firefox specific. In fact, let's go check that out. Sorry about that. Giant console. Yeah, so we might just have to do our own iterating. So we go to Google, see what we're seeing over here. All right, so we're in our list now. And we're in a scoped where we can't see. Yep, thank you. Yeah, the debugger is having a couple problems here. Yep, thank you. Okay, awesome. It did get all the elements. Look, we've got 377 of them. And so now... Oh, it was a bad idea to enumerate that, wasn't it? So what do we got? We got the overall HTML element. We've got the head. Great. And the okay, so it's doing a depth-first traversal, which is exactly what I hoped for. So we're going to get each of these items in line here, and we can see if our assertion about the description holds. So it does look like we're getting tag names, but I don't think it's going to be good enough to like differentiate between these two different metas, right? Like this is 2.6, and this meta that we were looking at right here is 2.5. So the, how do we want to play this? So we can definitely get the type via the class name. Like that's going to be, I think, the JavaScript class name. So like let's look at that real quick. If we do that and look at it, we get yeah, like it just is that. This HTML element is a known JavaScript, I guess, prototype class. Same for the head, same for the meta, so we could switch off of that just fine. So if we, so what would be a little interesting now is getting that whole list of different inputs, but I think we'll be able to sort of emulate that, having to read the class to do the read successfully just fine. So if we come over here, what we're going to need to be able to do to read things nicely is sort of mimic what Selenium's got going on right here. And we know that this one, for example, is an HTML input element for its class name. So what we should do is library.fs. So what we should do is do our read match based off of that, because that's what we were doing all that investigation for in the first place, figuring out what values we would need to pattern match on in order to treat the element as a particular kind of HTML element. So what we're going to do is, yes, switch based off of the remote object dot class name. We might want to codify this if we end up using it in multiple places, like turn it into a function. That way we can sort of in a sane way or in a unified way access it all the time. But if we end up with HTML, if we end up with HTML input element, we are going to get the value property, because if you go to here and look at this particular input element, it has a value property on it, or it should, yeah, value right there. It hasn't committed for some reason. It's probably due to whatever their like front-end UI framework is. But in a typical HTML input, like if there was an MDN example of it, you could plot value into it and see. But anyway, value attribute has the thing that we want, so we'll just return get property async value, and that will get us a string. Oh boy, we want to say JToken. So Newtonsoft.json, I don't know if you've used it directly before, but it relies a lot on implicit conversions of .NET base class library value types to JToken and vice versa. So we're going to have to open up newtonsoft.json.link to get access to the JToken class, and then do op implicit. So that is a function that's not going to work, so we are going to define a set of active patterns. So we're going to do this instead. We're going to say, here's our desired value, and we're matching against some expected. And this is going to be a JToken, right? And this active pattern is going to be partial, and it's going to return successfully if the JToken that we get is a string and matches our desired string. And this will help us match in a little bit more of a sane way. So we'll just say if expected dot type equals JToken type, JToken type dot string, and expected, I'm sorry, I'm bouncing all over the place, equals desired, then some else None. That's it. So what we'll end up doing here is use this active pattern to say JSON string. So if this element is the JSON string HTML input element, then get its value property and we're good. So some of the other special cases that we have to do are the same. And we can actually nest some of these right here. So if we go JSON string, we're going to have to verify this assumption, by the way. So let me, I know what we can do. If we go back to our Google page and we muck with the HTML and we create a new node. I think there's a way to, yeah, we're just going to go text area. We're just gonna hack some stuff in there. All right. So now if we look inside this div ID, there's this text area. So if we do a selector now for text area, we should get our text area, which is great. So now if we look at our text area, we're looking for the HTML whatever property. Aha! It is HTML text area element. So we've done a little bit of grossness. We will verify these on a page of our own with some of these test elements on it, but that is good enough for me right now. So the next thing is a select as well, because we see in Canopy for a select, the way they retrieve the text of it is they get the currently selected value, get all the options, and then pick the first element of the options list whose value is the currently selected value. And that's because in a select, the value, like the data value and the viewable value, are not the same. They can be, they don't have to be. But that's actually enough for right now. In every other case, we're just going to get the text property or the inner text. So for everything else, we're just going to go element.getProperty. Why are you not liking that? Oh, that's what it is. Element.getProperty async inner HTML. So that's if we go back over to Google, or it might actually be inner text is what we want. But what is text? So text.inner HTML is that, but it can be escaped and whatnot. So if you get inner text, you get something different. Okay, regardless, inner text is what we want. Inner HTML is what we got because I did something wrong when I injected that element. So we're just going to get inner text, and I should have gone with that initially because I remembered from looking in Canopy, the Selenium text attribute that I'm highlighting right now is actually just what the inner text property of the element is. So task.force put in a to-do for ourselves. So now we can read. So now we can verify that we can circle round. So let's clean up this test a little bit. Now that we can read, we should be able to read element, and we should be able to say that when we write this greeting, we can then turn right back around and read it, and the values will be the same. And now we can say expect equal what was written, and the greeting itself should have been able to round trip the greeting. And then when we have our elements, because we're getting all the elements, we should be able to expect we've got sequence equals, sequence starts. Okay, so we'll say this then. We'll say that, is there a 0, 1? Nope, okay, so is greater than. So we'll expect that elements.length is greater than 0, should have found some elements on the page. CTX, great. Okay, so we need to do something a little bit more now. We have a JS handle, and we have to figure out how to retrieve values from the JS handle. So JS dot. So it fetches a single property. Oh, because it's a J token at this point, so we need to stringify it. That's it. So this is a little weird, and we might want to write a comment or something telling us why we did this, but I think this is going to work for us. So now read should return string, which it does, and our tests should all be happy. Cool. I think for for symmetry's sake, we're just going to put the browser context in there because every other function requires it, and we want to be consistent, and we might end up needing it. So that's element handle option, but we know it's not none, so we can just continue on at this point. So now let's run the tests one more time. And then finally we will, I think, be at a stopping point where we can do some of the grunt work now that we have a sort of landing pad for the library. So I like having these functions because they're simple to do, but I don't like having to pass the context around. So as sort of like a next move, I would probably want to come in. Yes, thank you. You're very kind. I would like to come in and have an object API for this, just for being able to use it nicely. Hey, there we go. So that should have been that. So it looks like we did not get the correct value. So when we wrote it and we typed it, oh, you know what? I think I know why this is. So when we went into Google, when we went into the search page itself and we said, hello from Figurine, and then if we came in here and we got our search value and did input, where the aria label equals search. So if we go get our aria label input, our main search input, and we say input, and we look at the inner text, there's nothing there. Yeah, because they've got something in front of it. They yeah, that's a little unfortunate. So the part that's confusing to me is where that text is. Like, is it just sitting in memory somewhere? Anyway, so I don't know if anyone's seen that before, but that's mildly confusing, and we are just going to mark that test case pending, and we'll say that it's pending because the input element on Google's search page doesn't show the So this is one of those weird cases that I hit sometimes testing pages at work with Selenium. The way the page looks isn't necessarily representative of the way the data model of the page represents the data. The example I had just a few days ago was we were using Bootstrap 4 for a checkbox, like a select all checkbox, but we were using a particular image or glyph for the checkbox such that the checkbox looked like it was right here. Like the clickable input was right there. But the actual HTML checkbox element was over just enough, and it was underneath another HTML element. And so when Selenium tried to click on that element, it ended up misinterpreting the click. That little thing took me like 45 minutes to figure out. It was very frustrating. But as you can see, we're passing now, so I'm going to stop this right here and go up to our main directory, add all these things, commit initial implementations for, what all are we at right now? We are at read, write, URL, find many. That's okay. That's a decent start. All right, so now go to push. Oh wait, there's no remote. So we're gonna go over to GitHub. I'm gonna make a new repo for this. And it's gonna be called Figurine. A canopy style wrapper for the Puppeteer automation library for Chrome and Chromium. I like having a description like this because oftentimes I'll read a blog post or see a tweet for a particular technology and not know what the deal is with it. So we won't need to git ignore. Let's see if we have a license. We do have a license. What did we get by default? We got MIT, which I am perfectly fine with. So we won't need to do either of these things because as soon as we create the repository and add it as a remote, we'll be good. Remote, add origin, plop that in there, and then push. Oh my goodness. All right, so we push it up, good to go. So the next bit that we should see is, well, obviously I need to go to the README and do some information here. We haven't pushed a NuGet yet, so we're not going to see either of these. Yep. All the rest of this is just fine. All right, so we do have Travis. I think we have to go to AppVeyor and Travis to enable them. Yeah, ci.org. We have to enable them before we can begin testing our application through them. So let's go do that real quick and let's see how far our, there we go, sync the account, and see how far our out-of-the-box tools got us. Sign in with GitHub. Okay, new project, GitHub. All right, this is Figurine. Boom, we enable it. And there's Figurine, and we add it. I misspelled Figurine, didn't I? There's no E at the end. We'll go review that here in a minute. I want to start off builds right now just to see how far we get. So this guy's queued. Great, it's starting, and this is the array that we get out of the box for Mono. So this is all on different versions of Mono. We might want to check this out and see how far we get with, there you go. Okay, cool. So we do have .NET on here as well. So this is going to be using particular versions of .NET SDK. Sure. Let's see how these are going. We're packet restoring here. These are going to take a little bit because you end up installing mono from source in Travis CI. So we'll just let that sit for a little minute. What I'm curious about, so in our build.fsx, over here, we have the coverage report directory. I want to see where that comes from. All right, so we generate the coverage report. Cool, and I want to see what get release does. So that pushes the new version. What is our dist glob? Okay, so it's just pushing the NuGets up. Okay, so the other thing is, as far as coverage is concerned, if we do our build here real quick and let it run, I can show you what the coverage and alt cover looks like. And some people will push that up as part of like, here's the coverage on the latest release stats. I think it's possible to also add coverage badges from that up in here. I think alt cover actually supports JUnit output, so if your build tool like GitLab, for example, supports JUnit coverage reports, that'll work just fine as well. So it looks like we failed a build in AppVeyor. Oh, that's interesting. So this we thought might happen. The Chrome executable doesn't exist. And so our tests are going to have to actually learn how to, like, we're either going to have a configuration option that uses that browser fetcher that we saw in the API to actually pull down Chrome, or we will have to install Chrome as part of the environment setup of the test. So one of those two things. In addition, we got an error from alt cover. So there's a parameter there saying that our test coverage is below our expected threshold. So if we wanted to verify that real quick, yeah, so we can see those failures happening there. It's testing across different, what's the word I'm looking for? Different runtimes right now. We've got NetCore app and 461. So if we go kill the 400 different versions of Chrome I have open, I killed this one in the middle, which is why you saw it there. So now if we go to docs coverage, yep. No. I think that was the problem. Here, let's do this. Well, let's fix things. I really want to get these coverage things up so I can show you guys real quick. There. I want to turn headless back on. Generate coverage. There we go. Doo-doo. All right, so if that failed because of Chrome, I'm almost certain this one's going to fail because of Chrome as well. I just don't think we've gotten there yet because Travis is still having to install mono. Which, I mean, doesn't always take super long. It takes, I think, like 5-6 minutes. But it's more time than I want to just like sit here with y'all and wait for. So here we go. We got something over here. Cool. So the threshold was wrong. Oh, because I didn't clean up after that last test. So we're going to purge that real quick. Run that one more time. We'll get there, I promise. See, there's that alt cover threshold. Just to get a passing one, I might bring it down to like 60. A little bit of a problem. Directory for save files, blah blah blah, already exists. Let's go check that out. Oh my. So there's the coverage rules right there. Still not there. All right, so what do we got going here when we invoke this? Output directory for save files, blah, already exists. So let's do this instead. Let's just do this for framework net for app 2.1. Let's just run the .NET Core version of it. Or the whole framework one. Same deal. Awesome. Oh, let's do this. Tests that bin debug net 461 saved. Fine. Use the classic rm rf. Run our test again. So we're seeing something slightly different from when we were running Expecto manually, like doing .NET watch run, because this is in .NET test. And that may actually be the cause of some of our problems here. So we'll, if I can't get this to work now, that's okay. We'll get it to work. Just wanted to see my pretty coverage numbers. But it is actually quite nice when you get it right. You get the sort of colored line coverage, and you can click into call stacks and traces, see coverage by module and class and all that jazz. So there's definitely something stuck right here, which is unfortunate. That one I expect to blow up because we don't have 2.0 as a target. Yeah. Yep. Okay, so I'll get to that at some other time. Oh. Oh yeah, hold on. There we go. Yeah, so this is what it looks like. This is from back at the very beginning, before we actually did any coding here when I did that first run. But this is what you end up getting. You get like per assembly coverage blobs here. You can change the grouping as well to do it by namespace if you want. You can drill down and see which lines were covered. Go to particular methods and properties. So it's not too bad. It ends up working a little bit nice. Yeah, our auto properties here. So all in all, I'm generally a big fan of it. I got to figure out why it's not working right here, but you end up with a nice report that you can drill down into, and you could, like, this is all static stuff. You could push this directory to the GH pages or to a subdirectory of your GHPages branch and link to it from your README or whatnot, which is what I hope to end up doing with this right here. So I think that is actually where I'm gonna call it for today. We did a little bit of infrastructure stuff. I showed you the scaffold. We saw that the scaffold got us at least a build pipeline going, and it showed us that I had some harmful local assumptions in here, namely, like, the Chrome directory on my box isn't going to exist on a Linux machine, right? So we have a little bit of build automation we have to do if we want these tests to be runnable in CI, which we do. So we'll tackle that. We'll tackle, or I'll continue on to tackle some timeout stuff. We'll cover a little bit more of the basics, or a little bit more than the basics here, and we'll try and get at least half of what Canopy can do for some of these use cases, and then it would be cool to do some testing against I don't know, like the F# forums or something like that. So thanks everybody who's still here for hanging around. I hope this was useful in some way, if only to show that, yes, there is a whole bunch of hacky code that you can write in F#. This isn't perfect by any means. We've covered some like pain points around parsing JSON, but mostly it's just been learning an API and learning what we might need to do a little bit of browser automation with it. So thanks for chiming in.